Scientists have just confirmed a terrifying truth. We are surrounded. Millions of Rhino black holes might be swarming the edges of the Milky Way, forming a silent, impenetrable barrier of death. And the James Webb Telescope, it only recently found proof of their existence. For decades, the scientific world believed miniature black holes were impossible. By the late 1960s, we knew only one way to create these monsters: the violent collapse of a star born from dying suns. They were labeled stellar mass black holes. But here's the thing, not every star has what it takes. Exploding supernova with less than 20 solar masses. They only leave behind neutron stars. So, if stars can't forge small black holes, why are we suddenly so certain they exist? The answer is haunting, because we found monsters that are far too big. We now know that. Almost every major galaxy hides a super beast at its core, a supermassive black hole. Their mass? Hundreds of thousands to billions of times our sun. It's staggering. As early as 1971, theorists predicted their presence at the heart of galaxies. But as the evidence mounted, a massive question remained. Where did these titans come from? Theoretically, a stellar black hole could grow by slowly feeding on matter. But James Webb's newest data just shattered that hypothesis. Peering back into the dawn of time, the telescope captured several faint red dots. These are galaxies existing only 500 million years after the Big Bang. Incredibly. They already contained supermassive black holes, just 500 million years. That is nowhere near enough time for a stellar black hole to reach that size. Unless it defied every law of physics and devoured the universe at an impossible rate, while some hint at supersized feeding sessions. Most experts find that explanation weak. Then, a more radical theory emerged, and Webb's latest discovery might have just proven it true. There is another way to forge a black hole, one that doesn't need a star at all. The secret to a black hole is simple: pure density. When matter is crushed into a small enough point, gravity crosses a point of no return. To escape it, you would need to exceed the speed of light, which, as we know, is impossible. To reach that density, you need overwhelming energy. You must crush electromagnetic forces, force electrons and protons together, and shatter neutron degeneracy pressure, breaking the quantum law that says two particles cannot occupy the same space. The density required is beyond imagination. Consider a neutron star. Its density is already terrifying. A single teaspoon of its material would weigh as much as Mount Everest. But to create a black hole, you have to compress that entire mountain into a space 1,000 times smaller than an atom. In today's universe, only the fury of a supernova can do that. But if we go back to the very moment of birth, the rules were different. Let's rewind to the first second after the Big Bang. The universe was a super hot, super dense primordial soup. Matter was not uniform. Pockets of extreme density existed, while others were thin. Scientists believe that in those ultra-dense zones, matter collapsed directly into black holes, skipping the star-forming phase entirely. These are primordial black holes. The concept isn't new. It was first predicted back in 1966. But here's the fascinating part. Primordial black holes have no mass limits. They could be as massive as 100,000 suns, explaining the supermassive giants we see today. Or they could be microscopic. Imagine something the size of an atom, but with the weight of an entire asteroid. These are the true miniature black holes, as small as a single proton, yet packing the mass of a rhinoceros. Meet the Rhino black holes, but a critical question remains. Even if they were born at the start of time, could they still be here today? There are two hurdles. First, Hawking radiation. Hawking predicted that black holes emit radiation, slowly bleeding away their own mass, until they vanish in a burst of light. According to his theory, these tiny primordial holes should have evaporated eons ago. Second is the lack of evidence. We've never seen one form, nor have we directly spotted one. But recently, James Webb delivered two bombshell discoveries. In July 2025, NASA announced that Webb had imaged two ancient disk galaxies, caught in a cosmic collision. But strangely, Sitting right between them was a lone, supermassive black hole. It couldn't have been kicked out of either galaxy, because both already had their own central monsters. This third-wheel black hole simply shouldn't exist by our current rules. One team suggests it formed in situ, collapsing directly from a cloud of gas. At the same time, another telescope captured a different beast, QS01. Its host galaxy is remarkably small, and its composition is incredibly primitive. Its heavy element content is less than 1% of our Milky Way's. It is one of the most pure systems in the early universe. Heavy elements only come from generations of stellar evolution. The fact that ZO1's home has almost none means almost no stars have ever lived or died there. Therefore, ZO1 could not have been born from a collapsing star. It is very likely a primordial black hole. These discoveries aren't definitive proof yet, but they prove the early universe was capable of direct forming black holes. And these may be the ancestors of every supermassive monster in space. If this is true, then millions of tiny Rhino black holes must have been born alongside them. But wait, Hawking radiation, shouldn't they be gone by now? In April 2024, a revolutionary study was published in a leading journal, proposing that at microscopic scales, Hawking radiation might actually slow down, or even stop altogether. This means these rhinos could shrink to a critical point, and then just freeze, no longer evaporating. They could still be out there right now. This leads to an even crazier possibility. Could the mysterious dark matter be these very rhino black holes? We know the total gravity in the universe is far greater than what we can actually see. Something invisible is out there, forming massive halos that wrap around galaxies, holding them together with ghost-like gravity. And rhino black holes fit the bill perfectly. They have massive weight, they're invisible, and they are far too small to be detected by our current tools. They don't disturb nearby stars like the giants do, and they are nearly impossible to catch via lensing. In other words, within the dark matter halo surrounding our own Milky Way, there could be millions of rhino black holes. They are an invisible minefield, floating silently in the void. If this is true, our future dreams of leaving the Milky Way to explore Andromeda, they are in grave danger. A single probe could collide with one of these microscopic monsters and be instantly obliterated. We might be trapped inside a Milky Way cage without ever realizing it. Of course, space exploration is always a gamble with death. But the idea of being surrounded by millions of rhino-mass landmines, well, that sends a shiver down my spine. Are these rhinos the ultimate truth of dark matter, or just a haunting theory? We're about to find out.